Anybody look up for one, just out of curiosity, for one of the fungal infections, it's here, around El Paso.
That's that new one you were talking about?
There's not a new one, it's been around forever.
It's a fungal infection?
Fungal infection is a lung infection.
Causes pneumonia? What does it do?
It causes pneumonia, lung infection. Right on what?
Okay.
No, not TB, fungal, not TB bacteria. Huh?
Valley fever?
Valley fever, what's the other name for it, the long name for it?
Coccidioidomycosis?
Coccidioidomycosis, yeah, that's the name of it, coccidioidomycosis. But it used to be called San Joaquin Valley fever.
Oh.
Where's San Joaquin Valley? What do they do in the San Joaquin Valley?
Oh, the digging.
Digging?
Is that in California?
Yeah, it's in California.
Mining?
Nope, no.
Uh,
You're right, it's digging the soil, it's agriculture, it's a big it's a huge agricultural problem. The problem San Joaquin Valley fever is endemic everywhere where you have these alkaline soils in the deserts and places like that, and so it's here.
It's because they're digging and they're bringing it up?
Yeah, when they do
Oh.
grading and when they do stuff when they're planting crops and picking crops and stuff. That's just where they came from originally.
So it's easy to get infected is by driving through our Bakersfield?
Yeah. The only good thing about it, you can say it's a good thing, is normally our immune system is very good in taking on funguses, fungal infections. The problem is once they get established is when they become a big issue.
Because we can't treat them.
They're hard to treat, and a lot of times people are immunocompromised when they get them. So that's a problem. So what's the following pathogen does not fit the typical description of an organism?
Viruses? Wait,
Yeah, because the organism has
virus. Yeah.
Good. Could be a virus, right? They don't have any organized cellular structure, really. All right. What we're going to talk about more epidemiology. Incidence, portals of entry, modes of transmission, source of infection, symptoms, what's the disease course, what's the site of infection, and some virulence factors. All right. Epidemiology is the study of factors and events or circumstances that influence the transmission of infectious disease among humans. In English, that means what?
the causes or the mode of transmission.
Yeah, it all cause mode of transmission is all gonna be into part of that, but that's also more clinical too, right? Epidemiology looks at what more. They do look at that. There's a lot of crossover.
How it's spread?
The population, how it spreads, where it is. I mean,
So
where did I take?
it's not even at the chemical part of it.
Right, it's looking at it, how it moves through a population, how it can move through a population, and then once you know how it moves through it, what can you start doing?
Curing.
Not curing as much, that's later on.
The bacteria, the type.
The type, even that's more inside, even that, think about the AIDS epidemic.
Or snow.
It was almost 10 years before they came up with the first drug. So that was that.
Symptom?
Symptoms-
No, like with snow, isn't it? Because like how the sewer system, like, or the water system
You did
in that
but-
neighborhood.
But what can you do? What did I say? Once you know the reservoir,
You
He-
can reduce the risk factor by eliminating the mode of.
We prevent it, right?
preventive measures, you can start putting preventive measures. That's the thing, is once you know where it is, how it infects, what its reservoirs are, how it's spread, then you can start implementing what?
Preventative measures.
Preventive measures.
So
And that's the big thing, because a lot of stuff you can't treat. They couldn't treat HIV at first. The best you could do is try and prevent infection, right?
Yeah, until they could get a handle on it.
So that's a huge part of epidemiology. Incidence is the number of new cases of an infectious disease. Doesn't have to be infectious either, because you look at the incidence of diabetes, right?
Mm-hmm.
That occur within a defined population over a given time. Otherwise, incidence would be open-ended, right? You would never have a defined incidence because it's over a given time. A month, a year, 10 years, right? That's the incidence rate. But it's the number of new cases. I don't like reading what says infectious diseases because it's not just infectious disease. That's just what this chapter is talking about. Because you have the incidence of, what would the incidence of diabetes in El Paso be?
I
not the number, it'd be what?
The new.
The number of new cases diagnosed in El Paso in a given year, right? That's the incidence rate. You can have incidence of cardiovascular disease, so just scratch that out.
Scratch out.
I should have taken that out, I didn't know this one.
Scratch out what? Infectious?
Diseases, because it's not just, it is for this book, this chapter, but it's not for incidence itself. All right, prevalence is a number of active cases at any given time.
And new cases, right?
And, yeah, so it's both. So prevalence is gonna include new cases, right?
Yeah.
So all
Because-
existing cases.
Right. So if you look at something, and that's why you have to be careful. Sometimes they'll match each other, other times they won't. Incidence of flu is doing what right now?
Rising.
Rising.
It's going up, right? But it's an acute illness for about 2 weeks of duration, right? So what's the prevalence of flu in El Paso?
Could be depending on.
But is it gonna be close to the incidence, or is it gonna keep going up, keep going up?
It'll be, so it'll be down.
It'll be down?
Well, most of the incidents, right, because every time you get a new case, it'll be prevalent. And as soon as flu season's over, it starts to drop with the incidents.
Okay, so but that's incidence does the same thing.
It's the opposite.
But if it's an acute illness and you include incidence in prevalence, they're gonna be pretty what?
Together.
Related.
Yeah, because they're about the same, right? Because it's an acute illness, you get over it pretty quickly in a month. You usually look at it in a month. Most people get over the flu in a couple weeks, right?
Yeah.
So if you're looking at a month, they're gonna be pretty close, right? Unless there's some overlap, like, oh, I got it in August and then or not August, December. But if you look at the prevalence of hepatitis C and the incidence of hepatitis C, what is the incidence of hepatitis C gonna be in El Paso?
It's gonna rise, but steadily, right? Yeah.
Probably relatively stable, I would guess. I haven't seen any big Hep C outbreaks here or anything. But what's gonna happen to the prevalence of
Gonna raise-
hepatitis?
Well, it's gonna start going down because they found a cure.
Okay, without, okay.
Oh.
It's,
It's gonna rise.
I shouldn't use that. What's gonna happen to
It's
it?
gonna rise, rise,
Let's use
rise.
HIV. HIV infection. It's gonna do what?
Rise, rise, rise,
It's
rise,
gonna
rise.
keep rising, right? Because if something is untreatable or chronic, prevalence is gonna keep going up, whereas incidence a lot of times will stay stable.
Yeah.
So when it's saying define population, so is that when you divide the new cases by a certain population or just the area, in the area it's in?
What do you mean? Oh,
Because the
what's it?
incidence you do,
It's
is the number
area,
of
it's-
new cases divided by population.
It's gonna be a geographical area. So it can be El Paso, Texas, the US, somewhere, right? It can be any time, but so incidence better is, to me, is the number of new cases at a given time in a given area for a given population. That's what it is gonna be. So it's gonna be defined by population or area. All right. So right here. Incidence of disease, endemic diseases are found in a particular geographic region all the time at relatively low stable levels. Right? So the incidence and prevalence are expected to be what? Relatively stable over time. Same number of people are getting it, same number of people are gonna have it. Doesn't change much because it's always around. What is an example of that?
Malaria.
Well, let's say,
AIDS.
AIDS is a little bit weird because it's changed, because the incidence is going down, the prevalence is gonna be, so the AIDS has problems now, so it's kind of all over the place. Malaria in an endemic area would probably be going down. If you're in sub-Saharan Africa, where malaria is very endemic, you're gonna have probably stable numbers, right?
Right.
How about an example, in El Paso?
What's
Better
common?
Diabetes.
Diabetes would be one, but let's look at infectious disease. What's an infectious disease that is in this area all the time that we're
TB. No.
TB, yeah, TB is probably one. TB is pretty, TB's, so it's gonna be an endemic disease. TB's endemic pretty much almost both places. Hmm? Fortunately, STDs, they are endemic, but they do tend to go to, in fact, and we'll get back to that one in a minute now you brought it up, because it's actually causing some issues now. How about rabies? I like using rabies.
Oh, that's right.
Rabies always around El Paso?
Yeah.
Yeah, we have a huge endemic population issue with rabies. And there's always low numbers of what people potentially exposed to. Fortunately, people don't get it. Okay? I think of another one that's here. That's infectious. We're pretty lucky here. We don't have
Yeah.
Probably TB probably here one. It's because it's always around at relatively stable levels. So epidemic, is an abrupt, unexpected increase in the incidence of a disease over endemic rates in a short period of time, around 2 weeks. So you can have flu epidemics, right? You have flu, does anybody ever get the flu in August?
No.
Yeah. If you travel around and stuff, you could get flu in August. So it's gonna be at this really low endemic level. But starting in October now, flu season's getting bigger and bigger and bigger. What happens to it? What happens to the incidence of influenza? No, in October, November,
Oh,
December,
it's going up.
it starts going up, right? So that's an epidemic, and that's in a defined area, okay?
So it's nothing to do with age.
Epidemics?
No.
No, epidemics are just gonna be a sudden, abrupt increase in the incidence of a particular disease over a given period of time, usually about 2 weeks. Now, flu is a little bit weird because the flu lasts, how long does the flu season last?
Couple months.
Couple, 3 months, 4 months, really bad. But like these little epidemics of measles that are coming up now because people aren't what?
Vaccinated.
You get vaccination, so you have these little epidemics of measles where you get this big increase over a short amount of time.
Is that the thing like with the Ebola virus?
Yeah, those are little epidemics, yeah. Now you gotta be careful because you have things that are called sporadic, which are little bitty outbreaks, but sporadic ones are things that like E. coli, the Chipotle coli, those are gonna be little sporadic outbreaks, right? It's not really an epidemic in E. coli, it's more of an outbreak. Okay. And a pandemic is when it does what?
Spread the disease.
Beyond continental border. Pandemic means worldwide. So give me 2 examples of pandemic.
Well, when Ebola came over,
What about the bird flu?
like zombie
Could have been the
virus.
flu is
Oh,
one, just any
yeah.
of the flus are pretty much one, right? The flu every year is pandemic, right? Starts in Asia and works its way where? All the way around the world, right? HIV, is that a pandemic?
Yes.
That's certainly. How about TB?
Yeah, because yeah.
Malaria?
Yes.
So what does it mean that it starts somewhere and spreads?
Yeah,
somewhere
in
else?
another country.
You gotta be careful with pandemic, because the US tends to be US centric, so if we're not included in it, a lot of times we don't include it. Malaria is pretty much everywhere but where?
The US.
Yes.
The northern hemisphere, right? And even some of Asia has it, so it can still be a pandemic. Once it moves out of one
Country.
continental area, it starts becoming a pandemic. So you've got malaria in Asia, you've got it in Africa, Middle East, South America, yeah, right, not South America.
Would one rule to think of pandemic would be like it's endemic in another country and then it moves out?
It's more of a
Do you know what I mean?
epidemic in another country that
Oh.
starts to spread past those continental borders.
Okay.
Now, sometimes they never burn out.
Okay.
Sometimes they do. The flu's pandemic every year. The bird flu would have been a small example of a pandemic that did go away, right?
Yeah.
All right, so again, right here, this is gonna be what? Endemic means it's what? It's always around, so whatever this is, it's endemic to the
The area.
Western Hemisphere,
Yeah.
right? Rabies, say. This is sporadic, so we had a little outbreak here. Chipotle opened up a place down in Argentina. So we had an outbreak in Chipotle in Argentina, sporadic. An epidemic is gonna be what? Somebody brought over SARS, say, and you had a small epidemic of SARS in this area. Pandemic is gonna be where? You're getting massive outbreaks across continental borders.
So the epidemic usually like acute disease?
That is usually acute. Under its definition, it is. The problem is, you get things like the flu and stuff. Yeah, so, yeah, it usually is. Epidemic? Yeah, it's gonna be acute. You're not gonna have a long-term epidemic. In fact, it should have, right here, see? Short period of time, usually about 2 weeks. Now, it can be longer like the flu. All right, portals of entry are gonna be ways it can get in, penetration, if it can get through. Okay, how does it get through the system? I don't know why that jumped way up there. Direct contact is gonna be via infected tissues or secretions that come in contact with mucous membranes. Classic example is gonna be STIs. Now, what we're talking about, the prevalence and incidence of STIs. I still call them STDs, I don't know what schools are. I don't know why they haven't changed the name of them. What do they say? What's the issue with STDs now? Well, there's always been an issue with them.
Infection?
But what happened to them?
Are they evolving?
They're evolving, you're getting resistance to them.
Become resistant, right?
I don't have that graph. Do I have that graph of, or is that micro? I don't show the graph in here. So you look back in the, didn't I have that graph about the fifties?
Yeah, one micro.
That was in micro?
Mhm.
It went up and then it started to go down for a while.
So, yeah, let's look at the date here. Let's look at gonorrhea, okay? So, let's see, thirties, that takes kind of bad. 10, 20, 30, 40, 50s, 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 2000, 2010, 2015. All right. Gonorrhea did weird little things like this, kind of endemic, a little spike in the 20s, the roaring 20s, I don't know what that happened, it did, but then it went down. The depression. Nobody was doing that. Alright? Then you get over here, and then we, and then we get over here, and it goes. Scooch that over a little bit. Change my scale a little bit. So tell me what happened with gonorrhea.
Education,
Mm.
Did this go to
What's
the,
happening, they got the,
well, what happened here? This was relative, I mean, it's always been around, you go all the way back to the beginning of
Time.
civilization, right? And it's pretty much been around, but it relatively, you know,
Stable.
endemic levels. You really did get a little bump in the 20s for some reason. That's it, think of it, woo, party. Now the 30s again, but what happened here?
World War II.
World War II. A lot of returning soldiers brought some souvenirs home with them, and they weren't all guns. So you had this big bump here, and then when you came home, it settled down. But what happened here?
Sexual revolution.
Advent of the birth control pill, this huge surge, not huge, but the sexual revolution kicked in, and bam, massive increase in gonorrhea. Wasn't an issue because up until not too recently, you got gonorrhea, you got a shot, and it went away. I mean, I'm telling my microcosm before, people back in the 70s, you look back in it, it used to be kind of a joke. The buddies, the fraternity, I got gonorrhea, we'll get the clef, you know, like, okay, man. So, why did it drop off right here?
AIDS.
AIDS epidemic, HIV, all the sexually transmitted disease, because the mode of transmission, bam. Scary thing is what's going on right here in terms of incidence and prevalence.
Resistance, I think, right?
Nope.
No?
Because no one's as worried because they still think that you get the shot in the shake, right?
For what, the shot for
or
what?
because AIDS is
Gonorrhea.
critical now?
Right now, there's a strain, right, that's resistant.
Yeah.
Yeah, but that would be prevalent, and that would be a small, but not that many people have that many strain, but we'll talk about incidence.
Oh.
Why did you see this massive drop off and now you see this increase?
It's like how we were talking about how people aren't even too worried about getting AIDS because you just take a pill every day and you're just.
Most people now that fall in these categories were not around when the AIDS epidemic hit.
Oh.
When you didn't have a treatment, if you came down, if you got diagnosed with AIDS right about here, you had about a 10-year death sentence ahead of you. People panicked, people wanted to put everything. STDs went down. Now, even here, a friend of mine had HIV. He wouldn't even eat. He was taking so many pills, he said, I wasn't even hungry. You were taking up to 20 pills sometimes a day.
Wow.
Just to try and control the infection. It was a huge deal. Now what is it? Now it's considered a chronic condition. They've gotten down to 1 pill a day. So now a lot of people are like, what?
I'm not worried about it.
Yeah, I'm not gonna die from it, I'll take a pill a day, big deal. Still a big deal with me, man, it's because I was around or something, I don't know. But it's become a big concern because there's been a huge increase in the number of new HIV infections. Along with it, what else is going up? Gonorrhea and syphilis are both on the rise, and they haven't been on the rise in years, so. Spring breaks come up, just be careful. Just my PSA, again. Ingestion, a portal of entry, why do I have protective on there?
It doesn't pass through as fast,
But why would it be protective?
it goes through layers.
No.
Because of the way your food is prepared, maybe you could be.
No, that's the reason you get it
No, well,
sometimes.
that's why I'm saying protect yourself and cook your food right.
But is protective compared to the other ones? Is
Yeah.
that what you're saying?
Why is there some, why do I have some protective in here?
Is your body, like the liver, the metabolites and all that?
Yeah, but that's gonna be more, actually, your liver gets some bacteria in it, can be kind of bad with the proton pumps.
It's like what you were saying the other day, how our bodies are a tube, that like,
Yeah, I'm kind of with you, but why would ingestion be somewhat protective? I mean, if you think about how many organisms actually we really are ingesting a day, you'd probably be surprised. How come we don't get sicker than we do?
Is that acid?
The acid, right. The acid is very protective. A lot of most organisms cannot survive passing through the stomach because of the pH. The acid breaks most of them down. It's ones that have evolved over time to do that. H. pylori is really the mechanism. What does H. pylori cause?
Like, ulcers.
Ulcers, and it loves getting your stomach, right?
Yeah.
Gets down in there and hides underneath your mucous membrane and cause all kinds of problems. But it also goes back to the whole argument with probiotics, right?
Yeah.
If I just spend $50 for 2 weeks worth of probiotics, how many of them are actually making it through my stomach?
Not many.
1%.
It's a big, I saw an ad for a new one that actually they claim they have a special little protective pill that's a, so it's all marketing. All right, inhalation is gonna be what?
What type of diseases or?
No, but what inhalation is gonna be what?
What do you mean by?
Breathing it in, right?
Yeah. Oh yeah.
No,
Yeah.
we're
We're thinking too
I'm
hard.
going back.
So complex.
Not a trick question, but all of these involve what though?
Mucous
Mucous
membranes.
membrane. That's the easiest way to get in. Your skin is a very good barrier. It's very thick. The layers are shedding off. You've got a bunch of dendritic cells and macrophages that are crawling around inside of there looking for stuff. Your mucous membranes are how thick? You remember from A&P?
Very.
How? Very thin. How thick?
Super
I'll
thick.
leave you guys off. But 1 to 2 cells thick. So it's a very thin layer, very easy to get to it once it gets in there. All right, I brought this in. This isn't in your book, it's from here, but this is from the A&P book. So this talks about getting direct contact, handshaking, kissing, sexual intercourse, fights. Indirect, we didn't talk about. Drinking glasses, toothbrushes, toys, punctures, door handles, right?
Mm-hmm.
Mouse, telephone. Droplet transmission is what?
Sneezing.
This isn't in here, so I put these in because I think it's a little bit better, because this is, especially for clinicians, you guys are all in, right? Anything that's aerosolized within 1 meter. So when you sneeze, those big old pieces you see come out, those are droplet transmission. How far are they gonna go? About 1 meter, right? You cough, same thing. So whooping cough, streptococcal pharyngitis, strep throat, Airborne, on the other hand, is gonna be longer and more than 1 meter. Okay? So airborne transmission is much harder, and a lot of times it's on what's called a fomite. So dust particles, droplets carry more than 1 meter. Okay? Waterborne is gonna be what?
Streams.
Again, that's not a trick
Rivers.
question.
Water.
Waterborne, but it's also called the fecal oral route.
Mm.
Because it's talking about natural, not tap water really, right? It's really talking about stuff that's in the water. So if you go out and drink stream water, somebody's done what upstream from you?
Peed in it.
Yep.
Yeah, he pooped in the water. Foodborne, a lot of times goes hand in hand with what?
Water.
Waterborne, but not necessarily. Seafood especially can be different. And meat. Why is meat an issue?
It's good.
Okay. But why, say, we talked about ground beef versus steak in here?
Yeah,
Yes.
so the ground beef gets mixed
Yeah,
up.
I always say these things. Give me a second. Vector, if you would talk about vector mechanical, it's just gonna be what? That's physically moving something on the body. Cockroaches and flies are the main two that do that. Middle of the night, cockroaches run across your dishes at night, leave little friends. It happens. And then biological, these are gonna be, usually gonna be arthropod-borne. Okay, location, nosocomial, this is gonna be you guys, I'm blaming you all for this. Nosocomial infections are gonna be what?
Hospital.
Hospital acquired, developed in hospitalized patients. It's actually a healthcare setting acquired infection. Doesn't have to be in a hospital, that's just the one you hear about the most. They just put that guy in prison, actually, who was the CEO of that company that gave all those people fungal meningitis. Do you all remember that? If you had a micro with me, I talked about it.
I don't remember that.
Okay, and they talked about modes of transmission. So they had this massive cluster outbreak all in this country. Not massive, like 17 people, but for fungal meningitis, it's huge. Fungal meningitis is incredibly rare. It's also really hard to treat. But when they saw this cluster of it, they're like, what in the world's going on? Why do all these people have fungal meningitis? Turns out they were all getting steroid shots based on a particular company that during the manufacturing process, they failed their QA/QC and they were getting fungal spores in the steroid. So, two things these patients were doing. Directly injecting fungal spores into their body, and what do steroids do to the immune system?
It drops your immune system.
Compromise your immune system, so these people, like a double whammy for these people. A few of them died, but I just read about 2 weeks ago that body put them in prison.
Why did he alter the?
Yeah, just bad, and they tried to cover it up and some other stuff, you know.
Could, nosocomial infection also still fall under, like, a doctor or nurse wearing their dirty scrubs, going out to lunch that way and
Oh.
transmitting it that way?
It would to me.
Mhm.
I'm trying to think about that. Probably not. We're probably gonna make that just a, nah, probably not. That's more of a hygiene type or sanitation type thing, lots of sand. I would, because that's a huge issue, but, I mean, not a huge issue, it's potentially a huge issue. But it generally has to be acquired either in a healthcare setting or directly as a result from a healthcare setting, like the shots or something. I don't know if I would call that one. I know some call me. That's a good question. I'm curious to see what comes up with that. It just doesn't happen that often. It's just gross. Community acquired, okay, I'm just throwing the community acquired, is acquired outside of a healthcare facility. What's a host? Talk about that at the beginning of this one. I'm trying to do this chapter.
Somebody carries it around with them.
Parasites.
Object or substance from which the infectious agent was acquired, in this case. A host is also an organism that what?
To carry it.
Allows another one to survive and live in it or on it, right? All right, maybe endogenous or exogenous. Endogenous means what?
Inside,
Comes from inside of you. Exogenous means what?
outside.
Outside. All right, we're almost there. It's been like a long week to me. Pathogenicity is the ability of a microorganism to cause disease. Can you cause disease? Are you a pathogen? And we talked about true pathogens versus opportunistic pathogens, right? What's the difference?
Opportunistic is when you're immunocompromised.
Or something, you talk about immunocompromised, you brought up the fact that sometimes things get out when they're not supposed to be. Virulence is the degree of pathogenicity. How virulent is an organism? Okay. And you have different strains of the flu that are more virulent than others. The bird flu. It's harder to catch, but once you catch it, it's gonna make you what?
Sick.
sicker, right? Potentially sicker, right? So different factors, I don't memorize all these, I just threw a few in here. Adhesion factors, biofilms, these are in your book though, so look at these two. Well, actually, they're on your book, so better pay attention. I'll go through one time. What's an adhesion factor? Let's stop and just go over it.
It's how the virus can stick
Like,
to.
membrane?
Right, the fibra, yeah. It can grab a whole, and it's also protein receptors, mannose receptors. The whole point is, if an organism gets inside of you, let's say a GI organism, a gastrointestinal one, and it can't grab a hold, what's it gonna do?
Go right through you.
It's gonna go through it right, we talked about that. It can be protein, it can be a couple other ones. Biofilms are going to be the same thing. Helps them adhere, helps them stick together, protects them from the immune system somewhat, protects them from desiccation, from everything else. What's the classic example of a biofilm I talked about?
Plaque.
Dental plaque. That's a classic example of a biofilm. By themselves, those bacteria aren't that bad. They start working together. I just got back from the dentist, trust me. And a biofilm. Well, that was really gross. Invasive factors are gonna be what? These two are different. People get confused.
The
Extra
enzymes
set.
and protein, so it'd be like the catalyst,
It could be, well, what would they do?
will speed up,
You know, but think of what they're called.
catalyst, will they speed up? So the
Invasive.
disease, it speeds up the.
Not the disease, because these are invasive.
Colonization?
It can't speed up colonization, but how?
Um,
Who have marker with me?
by spreading it, or multiplying
Yeah, but what does invasive mean?
it?
An invasive factor, invasion, what does it mean?
So get inside,
To get inside of you. So a lot of these things are gonna be extracellular enzymes that break down collagen, break down the tight junctions between your cells, break down extracellular matrix proteins, things that break it down, allow it to get in easier. They are not toxins though, that's the difference.
Like that one that breaks down penicillin, like the penicillinase.
That's gonna be, an antibiotic resistance mechanism, that's a little bit
No,
different. Yeah, you can maybe throw that into an invasive factor, maybe actually.
Yeah.
Cause it lets it survive better. It'd be a little bit like a subset of that. Toxins actually cause what? What does a toxin do?
we have like neurotoxins.
That's what gets you sick.
Chemotoxins, you got neurotoxins, you got cytotoxins, you got
Internal,
glucotoxins, you got hematotoxins, you got. What does toxin do? What does it do?
makes it,
Hmm?
It's like it makes us worse. It makes it worse. It
It
makes
kills
us
the
sick.
cells.
Yeah.
It actually kills the cells, damages the cells themselves. These things don't kill the cells. They break down extracellular proteins and lipids, stuff like that. Toxins are actually killing the cell. Okay?
so with the invasive, because that's what the proteins carry, right, the code?
Which one?
Is that why it doesn't, is since it's an enzyme, it multiplies?
Well, it's an enzyme, okay, let's look at the one that salmonella has. Salmonella gets in your gut, right?
Yeah.
So you're inside of your small intestine here. And salmonella's here. He wants to get inside better, right? So what these invasive factors are gonna do, they secrete collagenase and some other ones that break down the proteins and the collagen fiber basal membrane and allow it to do what?
Get in.
Get inside even more. Hasn't killed the cells, it's just broken down some of the connections and some of the blockades to keep it out.
Mm-hmm.
Then it's gonna get in the bloodstream and go for a ride. So has it killed these cells? No. A toxin, if you got shigellosis, it's gonna produce an enzyme, a toxin that's gonna get in there and actually kill the cell. Now, it can still now do what? You can get inside of it once, of course, the Shigella doesn't do that much. But that's the difference. They both are virulence factors, they just work differently.
Mm-hmm.
You also have ones that break down the oils and stuff in your skin that can get through some of those. They're not toxic, but it allows them to get inside. Evasive factors now are gonna be what?
How to get away from our immune system, like
How to get away from it or what?
How to stop it, basically.
How to stop it, how to avoid it, how to hide from it, any way they can protect you from the immune response. In this case, some are going to be anti-phagocytic factors. What's one of the big anti-phagocytic factors?
To not, from,
To
protect
get
from
from
macrophages.
eating,
For
getting
macrophages, but it's going to be those capsules.
capsules.
It's actually part of a biofilm. Capsule, it's going to be a layer of glycoproteins on the surface of the cell. The two things that make it invasive factors. It can hide from the immune system,
Yeah,
they can't see it, and if it does detect it, it can't grab a hold of it.
yeah.
So both of them are going to be invasive factors. One of them's going to be hiding, the other one's going to be anti-phagocytic. I can see it, I'm a macrophage, but I can't what?
I get it.
It's like I'm trying to think what they used to be. Back in the old days, they used to do it in this crap. What am I down from back in the day?
So what is it when it's similar to your own body's genetic code and it won't notice it?
That's,
Tolerance? Is it about tolerance or,
I don't know.
could you have to be, now you have another thing, it's called, what do you mean similar to your own
Well,
genetic?
when it won't, I guess the macrophages won't like activate
Recognize it.
Recognize it because it has a similar, I don't know if it's structure, genetic code.
I think it's that capsule that you're thinking about because it uses our membrane.
So
No, not
to
the
make
capsule,
capsule.
that's not
it
what's
mimics,
before.
it mimics. But I don't know.
There's a thing called molecular mimicry,
No.
but that's autoimmune disease mediated, that's like rheumatic
Oh, the
fever.
envelope. Are you talking about like the
Envelope
envelope?
virus, oh, you're talking about envelope viruses?
Yeah.
Yeah, but they still usually have a lot of glycoproteins to get in that same server. Now, some of them that can do that are parasites. Some of the parasites can actually sort of start mimicking you a little bit, and that makes them hide from the immune system, but I'll have to look and see what we're talking about there. Okay, symptomology. Oop, specific, reflects a sign of infection. That's what it means, a specific symptom. Diarrhea, sign of the infection, right? Rash is also going to be what?
Side of-
Contact dermatitis is going to be what? What is contact dermatitis? Or what is it?
Touching, you catch it and you touch it?
What?
When you touch it and you catch it?
Yeah, well, contact dermatitis is when you get a rash or something, dermatitis from contact with something, right? You brush up like this. Convulsions are going to be where? You got convulsions, you know where what is.
In your brain.
It's in your brain, right? You don't have to be looking around for the site of the infection. Hemorrhage, you're bleeding from somewhere, you can usually track that down, hopefully, right? Pneumonia is going to be where?
Lungs.
Non-specific can be shared by a number of diverse infections, such as fever. If I have a fever, is that indicative? Is that going to tell me what I've got?
No,
No. If I have malaise, is that going to tell me what I have?
no.
No. If I have a headache,
Well, no.
then necessarily not like convulsions. Convulsions
Yeah.
are going to be a problem with
You
executive
could be
activity.
dehydrated or.
Yeah.
It could be dehydration. It could be what? Had a little too
Blood
much
pressure.
last night.
Yeah.
Lack
Could
of
be
sleep.
Blood
any-
pressure,
Any
fever.
type of infection. Good. I love this one. I love they put that. Obvious. Oh, yeah, okay. Predictable pattern, but that's what they're really talking about here in terms of symptoms. Somebody comes down with the chicken pox, you know the natural history of the disease, how it's going to progress through,
Yeah.
right? Mumps and measles also. You see those, you know what it is. Okay. Covert may require laboratory testing to detect. We talked about this. Hepatitis. You can have hepatitis your entire life and never what?
Know it.
Never have signs or symptoms of it, but it can be detected what?
So it could never
So-
manifest.
That's to be